Okay. This is something I'm actually excited for, this particular project. So, I'm just very glad that I get to work on it. Um, just to give like a little introduction to what this actually is supposed to be, this is going to be a 3D platformer with rhythm elements. That's going to be difficult to do. Right now, today, my objective is only to get the basic controls that involves movement on a 2D plane and not constrained to a 2D plane, but you know, like how 3D platformer movement controls, and camera movement. I'll feel confident that I can get those two things working on their own. Even if they're quite rough, I can probably get it to happen. So, let's do that. So, the first thing that I'm going to need for something like this is just to decide how I want to organize this. So the resources folder, I'm probably not going to be putting anything in here. I have no idea what this file is, but considering that this says Android Store and Google Play, this is probably something for phone development, and I'm not doing that, so I don't need you. Tutorial info, I'm pretty sure this is info for the URP, so like what appears here. So let's just remove those, and we'll check YouTube tutorials if we need to. Right. This thing reappeared. Go away. You also go away. What the hell's going on? Hmm. Let's see. Why did that reappear? That was weird. Well, this is all probably fine. And this is the things that are needed for URP to happen, so I'm not going to touch those. For scenes, I have this sample scene. I don't want to have just a nameless sample scene. This is going to be my own test scene. Right, because I'm working with somebody else, I want to tell them to not touch this scene. This scene, don't touch it. This is mine, right? So after this, I want to see the resources file. Yeah, that's fine. That's what it should be. Okay. So, there are a couple things that I want here. Global volume. Okay, we're gonna have to go on Google and see what the hell that does, right? Because I have no clue. Global volume. Unity. Global processing volume. Okay. Creating global post-processing volume. Screen-based image effects add specialized filter to the application camera, which can be used to drastically increase the visual quality of a project. Unity's post-processing stack replaces various iterations of screen-based image effects and combines them all together in an easily configurable way. In this tutorial, you will learn to create and configure post-processing stack. Oh, so this is some post-processing shit, probably for URP. So like if I check the camera, right? If I check the game, there's a volume and probably do a couple of things, right? And then let's say a bloom, like way more intense. No, that didn't do anything. Okay. Yeah, but it's definitely changing something. It's just that I can't really see it over the vignette. Yeah, you can see it to the corners. Okay, so this is some post-processing shit. I definitely don't want to bother with it yet, but I definitely also do want to have it eventually. This is the visual part of the game that I'm not personally going to be the one dealing with. So I'm just going to remove this for now and then bring up the possibilities of it to my partner on this. So, ooh, what are these funny buttons? Does this have to do with URP as well? Environment, camera stack, skybox, solid color, render texture. Alright, just let's not bother ourselves too much with it. Right. So first of all, let's put this display to Full HD, that's what it should be. Full HD at least, right? Then, there's a couple things we are going to want. Just as project setup, if I'm going to be playing with the controls and I want the player to control in a certain way, then I want to have a certain also yeah, that's what I want. I do want to have a certain package. So hold up, why are these installed? Did that come with URP? I remember having to install them last time. Text Mesh Pro, yeah, that one just comes. Analytics Library, URP, Unity UI, version control, Visual Scripting, Visual Studio, XR Legacy, Visual Studio Editor Timeline, Test Framework, Advertisement. Okay, let's take off some stuff that I know I'm not going to use in this project. Advertisement, just go away. This is why a project weighs like fucking a lot by default, doesn't it? Visual Studio Editor. Sorry, Visual Studio? I'm not using Visual Studio, I'm using VS Code. Aren't I? Let's double check that. Why did you come back up? But I deleted you. I deleted you twice. What the fuck is that little file? This is Visual Studio Code, isn't it? VS Code. It keeps fucking with me that they have the same name. This is Visual Studio Code. Okay. Go away. So I don't need the Visual Studio Editor, but I do need the Visual Studio Code Editor. Okay, Universal RP, Unity UI, Timeline. I know that it's powerful. I've never used it. Maybe I will, so I'll keep it here. Test Framework. This is probably necessary. JetBrains Writer Editor. Integration for using the JetBrains Writer IDE as a code editor for Unity. It adds support for generating and okay, well, I don't have that IDE. So, no, go away. Why are these here by default? Surely that should be prompted, right? Like, people don't generally have more than one IDE that they want to use within project, are they? Test front, yeah, I probably want that in-app purchasing. Okay, one common API across all stores, automatic coupling with Unity Analytics, iOS, Mac, tvOS, Google Play, Windows, and Amazon App Stores. Unity distribution port. Yeah, I'm not gonna do any of this, so just go away. Analytics library. That one, I'm afraid if I remove, it's going to fuck with things, but you know, otherwise it should be fine. Sprite and tilemap editor, I know that I'll want them. So, beyond that, I know that I am going to want the input thing. I forget what it's called. Input system, yes. It's weird that it's not there by default. I also... Oh, mathematics? Okay, why is this not showing up in the other category? Like, if it has the tick, that means that it's there. It's pretty decent, the new input system package, but the native platform backends for the new input system are not enabled in the player settings. This means that no input from native devices will come through. Do you want to enable the backends? Doing so will restart the edit. Yeah, sure, whatever. You want to save the changes? Yeah, sure. You'll restart on your own, right? I don't have to go up here and click it? Yeah, you're restarting on your own. Okay. So, just to tell you a little bit while this starts up what the whole idea of the project is. This is a 3D platformer. Think like Mario 64 or a short hike, that kind of game, right? Not in terms of vibes, in terms of overall controls and stuff. We want to make it like really oniric, really esoteric, like in terms of visuals. So the idea is to have the levels be visually and structurally similar to like the floodless levels in Super Mario Sunshine, with a bunch of moving platforms and stuff that's floating in the air without much justification. The idea is that it's going to be a rhythm-based platformer, which is going to be difficult to make because I've never done something like that, but that's exactly why I'm excited about this. We have a couple ideas for rhythm mechanics, we just have to expand on this, but the basic mechanic is pretty much settled in stone. But I'll get to that when I get to that. Today, that's not going to be that. Today, it's basic movement, and basic movement is not going to be dependent on the rhythm mechanics. In fact, the rhythm mechanics are not going to be that deep, but they are going to be versatile. Like, basically, every movement, every move in the game that you require for that sort of stuff is going to be rhythm-based. Okay, so I know that I want the input system. I also know that I fucking hate you. Go away. The input system. Do I want the Pro Builder? I feel like I don't, right? I feel like that's only going to mess me up. Like, it was a bit useful last project, but it just didn't do a lot. Like, I just didn't know how to use it very well. What else? There was something else that I felt like I needed to import. Photograph sequences. Okay, whatever. Let's just call it done here, and if we find later that we're missing something, we'll just add that on the fly. Right, so to begin with, fresh project. That always feels so nice, seeing everything empty, just loaded with possibilities. Let's get rid of the light. Actually, let's not get rid of the light. Let's begin. First of all, I want a cube. This is going to be my floor right now, and you are going to be, let's say, 100 by 100. That's a big, nice, wide cube. I would like it if this cube had some sort of texture to it, just to like be able to tell distances apart a bit better. But let's not bother ourselves too much with that right now. Instead, in order to be able to tell distances, we're going to place some reference objects somewhere in here, right? Just like be able to tell that stuff. Right now, we are going to be settling with this. Actually, do we want a big cube? I feel like we don't want a big cube. I feel like we want a plane. Yeah, there you go. That's better. So we'll just settle with this size for now, and then we'll make it bigger as we need it. So right now, what do I want to do? I want to make movement and I want to make camera movement. I don't want to make jump yet, but I do want to have some gravity, so that's gonna need some paying attention to. This is our floor. It has a mesh collider and a mesh renderer, and that's all it needs to have. So, first of all, we're gonna create a little 3D object. This is going to be a little capsule. The proportions of it are going to be decided once I have the 3D models for the guy, but for right now, it's just going to be a capsule. So I should be mindful to keep all my scripts to be able to work with just other shapes as well. Although, to be fair, I probably would make a 3D model that has the collisions of a capsule anyway, so that's not going to be an issue. This is going to be our layer for the moment, right? And this is looking a bit tiny, so let's just make it bigger. Let's make it 10 by 10. There you go, that's some running space. Right, this is our player right now. So, what do I want to give this player? First of all, this player should have basic movement. Let's remove this capsule collider. I don't want you, because I am going to instead be using a character controller, and this comes with its own collider. Oh, that's not what I put in. No, character controller, not character joint. There we go. That's a capsule. That's a capsule collider in and of itself. Okay. So, then we are going to be having to do a couple of things. First of all, let's make a folder. This folder is going to be for our play. Actually, do I want to make folders per the type of thing or per the thing that I'm making? I think like per the thing that I'm making is probably easier. So like I'll make a folder for the player, right? This is going to be the place where I put everything relating to the player. So first of all, this player prefab that I'm going to be editing today. Then I'll also make a subfolder within it that is scripts. This is for the scripts that belong to the player. And in here, we're going to create a new C# script. But before that, we're going to create a control thing. What was that called? Volume profile, prefab, audio mixer rendering, controller, physical material, GUI skin, input actions. Yes. This is going to be the player actions, right? So these input actions are going to have a couple of things. I'm going to make this different from how I did it last project. I'm not going to be saving these to a script. I'm going to have these broadcast messages to the other things. That is simpler, it is slower, but just a little bit really. So first of all, we want to have two control schemes. One, keyboard plus mouse, and this is going to have keyboard is required, mouse is required, and we're going to have another control scheme that is controller, and I'm gonna have to test that out later. And this one is going to have a gamepad. It's going to be just any gamepad works. I'm going to hope that I know how to make this work. So for all control schemes, we're going to have an action map, and this is going to be movement, right? So for this movement, what do we need? Just basic movement, just that. We are going to need, first of all, a action that is going to be movement. Just, let's call it walk, right? So walk is going to be it's going to need a binding with two modifiers probably, right? No, it's not. It's just gonna need a binding, right? This binding is used in keyboard and mouse, and it's, yeah, this is going to, yeah, it needs a value. This value is going to be a vector 2. So then, yeah, then we need a up, down, left, right composite. There we go. That's what we want. So this is going to be W for the up, S for the down, A for the left, and D for the right. And this is keyboard plus mouse. We also need another binding, and this is for the controller, and it is gamepad left stick. Yes, that should do it. We're going to test this afterwards, how this works. In any case, if I write my functions well, I should only need to play with this and not have to modify any scripts. I mean, this makes it pretty easy, because this only gives me a 2D vector, right, to play with. Right, so we'll save this as it is. We're just going to focus on the walk for now. So this player then is going to need a input manager. No, not an input manager. An input player input. There we go. And this player input is going to need the player action mapping here. And the default scheme is just keyboard plus mouse. We are not going to assume that you have a controller until we feel a controller happen. Default map is movement. Let's keep that for now. We can adjust that on the go, on the fly. Right. So then we are going to need the script. Most basic script that we're going to need is just walk around. I wonder if I should have just a character controller script or have various scripts for the different parts of movement. I like to be very modular to a fault, really, with my coding. So I feel like I want to have various different types of. So I am going to make a script that moves the player, and I'm going to make a script that catches the I'm going to make a script that catches the input from the controllers, and I'm going to make a different script that actually moves the player, and they're going to reference each other. They're going to be pretty well married. Why? This is because I want to have a script that only needs to be given a vector and then to execute movement, so that I can then use that script on an enemy, and instead of putting on this enemy, instead of linking it to the player detection of the controls, linking it to a little AI script. AI, a little artificial a little controller that will tell it where to go with other parameters, such as, fucking the distance from the player, I don't know, whatever the fuck. Right. So, we are going to have detect input. Detect input. This is going to detect all the input, because, like, as much as I want to be modular, I don't think I'm going to need to detect all of them separately. So, player actions within players should broadcast messages. What does invoke unity event means anyway? Oh, this just does events on its own. This just does events on its own? Well, hold on there. I may not need a detect input thing anyway, then. If this can just send Unity events on its own, then I may be able to get away with just making the action, the reaction to those scripts, and then this will be the thing that detects the input. I mean, that makes sense. Why wouldn't it be, right? And then I don't have to worry about names of functions. Well, let's test that. This is going to be really good if it works. You need to go away in that case. And then create a C# script, and this is going to be movement execution. Movement execution. Right, so I'll go to player actions. So, no, not you, go to you. Movement, yes, in movement, you have walk with its own callback context. So now movement execution. We don't need to initialize any values as of yet, so let's just get rid of this. And we are going to get rid of this, actually. I don't really want this. So I want to give you your own function that it's going to be a public. It has to be a public so that we can call it from a Unity event. Public debug. Let's give you a void. You probably are going to want, you're going to give it a callback context. Okay, what did that mean again? Let's get a reminder. Callback context Unity input system. Input action callback context. Information prior to action callbacks about what triggered an action. The struct should not be held on to past the duration of the callback. The action that got triggered is declared like that, cancelled, whether the action has just been cancelled. Control, input, control. Okay, so... Okay, Unity engine point input system. So I probably need to include this. Input system, and then you are a callback context that I'm going to call just cont. We're going to figure that one out later. So then cont point cancelled. Okay, input action, the action that was triggered. Point action, and we're going to like debug point log this, except I can't call this debug because then it's going to, yeah, let's just call it debuggy. Just so that I have something to call, alright? To see exactly how this works. Double check, you know? This is all a learning process. Okay, there's an error. The type namespace callback context could not be found. Okay, so that's probably because it's not just callback context. It is input action point callback context. I really wish that the documenting for the packages that you can download into Unity was written in the same format as the documentation for base Unity. Then I would only have to learn one of them. Programmers are really bad at usability, as usual. Let's see. So you need to have this script then. Just add it to you right here. Then this script needs to be referenced into events. So the movement event is going to need to know about you, and it's going to need to know to call debuggy. And then whenever I press the keys, that should print a message on the console, if I understood how this works. Okay, so it is printing a message. Movement walk. Okay, so this, what this is printing is then the callback context. So then I can take from that callback context an action, from that action, then only then, yeah, then from that action I get the stuff that I want, right? Note that actions are generally frame-based, are not generally frame-based. What this means is that an action will observe any value change. Input action. This is a constructor. I don't want that. Properties action map. The map that the action belongs to. I don't want that. Active control. The currently active control that is driving the action. Right. Don't want that. Binding mask. Don't care. Bindings don't care. Controls also don't care. Enabled. Whether the action is current. Yep, don't care. Expected control type, don't care. ID, don't care. Interactions, don't care. Name, don't care. Face, don't care. Processors, don't care. Triggered. Okay, whether the action was triggered. This frame. Okay, point, action, point, trigger. Actually, this is not, like by virtue of your calling this, then triggered is always going to... Actually, let's test that. Let's just try a bunch of shit and see if it ever prints false. It shouldn't. And if it doesn't, then that means that I've somewhat understood how this works. Take me back to my days. Da, 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 da. Okay, so let's see. Are you printing false? Okay, so it does print false. That means that there's something here that I haven't understood. When do you call these events? Maybe I can find that information here. Default dead zone, button press, point, button release, update mode, process events in dynamic update, tap time, slow tap, hold tap radius, multi-tap delay time, for devices, motion usage, editor. Yeah, none of this is useful. Okay. So why are you printing false? What I am printing is triggered, whether the thing has been triggered this frame or not. When I press a thing, it seems to print false and then true, which means that this debuggy is happening twice for each press. Does that make sense at all? Not exactly sure. I don't think it makes sense, but I'm not sure how to, what the issue, like why would this even happen? Let's test it again, see if I can see exactly what's going on. So when I don't press anything, nothing gets printed. So I know that this isn't happening, this isn't being called every frame. When I press the W button and then hold it, it prints false, then true. So that means that that event is being called twice. If I press another button while I'm pressing that, an additional true gets pressed. If I release one of those buttons, true gets pressed again. If I release the other, it's false. So each of these prints is one execution, and exactly only one execution of this function, which is only executed every time that you call this. So why on the first press is it executed twice? I probably am safe to ignore it and to just check if this is true and then only then react. But I want to know how this works, right? Because that will help things. So what am I printing exactly? Triggered. Whether the action was triggered. That means had performed called this frame. Okay, what is performed exactly? Is the event that is triggered when the action has been fully performed. Event that is triggered when the action has started. These are events. Okay, so I probably don't want triggered in that case. Type, behavior type of the action, input action type, clone, disable, dispose, enable, read value. Okay, this is probably what I want. So cont action read value, and the type of value is vector2. Right? This should print me the vector that I want. So if I start pressing, yeah, it's 1, 0, so 1 on the X, yeah, release 0, 0, 0, 1, 0, 1. Okay, so why does it get called twice? That is my biggest concern right now. Why is it called twice? Because understanding that is going to be important to see how I work with these Unity events. Yeah, let's actually search that, because I may need a reliable way to count presses, and in that case, I want to be sure that they're going to happen only once. So, Unity input system. Why do events get called twice? Okay, why events? Hi, I just started Unity faced with strange issues. Unity's new input system performed event fires more than one. I did not visually add it. I added it inside my script. This script is also attached to different objects at visual side. Please look in Awake and mouse on left button. I mistakenly attached my player script to one more object, so that caused additional debugging message. Okay. So, did I do that by accident? Are you somehow attached to two things at once or attached twice? Is movement execution script happening twice for some reason? It shouldn't. Everything in here should only trigger when this happens, and that is when walk is pressed. So you're not answering my question. Then the input contains triggering events multiple times. I have then attached the player input components that invokes Unity events in the following way. I'm finding that when I press a button, the associated event is called multiple times. Twice when the interaction type is set to tap, and 3 times when it's set to press. Is this a bug? If not, and this outcome is intentional, how do I go about making one button press equals event is called once? Happy to provide more information. On the side, I've also noticed that adding the input system package sample project has broken all my old methods of input. Yeah, that's what happens. This is intentional. If each action goes through a started, performed, cancelled cycle with a callback triggered for each step in the process. Supply context object supplies information about this. Oh, okay, so this is going to be... Oh... Adding the input system to a project. Okay. So this is some useful code. Okay. So let's check this and see if I do this. Okay. Alright. So if I add this code, right? And then just tidy it up a little bit. Did I ever tell you, one of the people in my class just gave me shit for inlining. Actually, I think it was one of the teachers. I certainly hope it wasn't one of the coding programming teachers. It gave me shit for inlining the end brackets with the else ifs and the open brackets with the if statement. Like, the whole argument was that code is supposed to look tidy and shit, which, like, it's not wrong, it does. But first of all, to me, this looks way tidier. And second of all, it's not like a thing that only I do, it's a thing that many people do. And what he said was, in a professional environment, this will not cut it. And here's the funny thing. This is why Visual Studio is so good, is because it does that automatically. God, that was a bad take. Like, first of all, any IDE that is worth anything will do that. It'll let you set up so that it does that automatically. Visual Studio just does that by default, right? And look, you can disable it too. And like, what's that shit about it not working out in the professional context? What do you mean that this is the reason? That you mean that this is the reason I'm not gonna be hired? This instead of this? Nobody cares. Nobody cares about that one. No, this makes code look tidier, and it's a thing that programmers do, like a lot of them. Nobody's going to be BSO at by you know that. No programmer is going to be confused by that, you know? Like, maybe, at most, they will request that I don't do that, and then I can comply, because it's a good thing to be consistent, but, like, otherwise, who gives a shit? So that was a dumb take that I had to deal with. Okay, So yeah, I guess I forgot thing here. And here, this code is weird. Maybe there's some syntactic sugar that I'm not aware of because that was definitely C sharp. The name context does not exist in the current context, right? Because it's not input action point called by context. Cont, this is cont, there we go. Cont, 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 okay. So let's see how this works, right? Depending on what the things here say. So, okay, so I press a button, the action is started, then performed. I press another button, it's just performed. I release one button, performed again, I release the other, cancelled. Okay, so did that last cancel come with another performed? No, it didn't. Okay. So now we know how the flow works. So given now that I know that, I can begin programming this. So we can ignore the started because every single time that I change it is going to be performed unless it becomes 0. In that case, it is cancelled. So if context point started, then return, and do that. Otherwise, it's going to be either performed or cancelled. Performed when it's something not 0, cancelled when it's 0. In either case, I'm going to want to update my movement vector, right? So, in that case, I can... Okay, let's try that again and see if I'm getting a single vector readout for a single button press, right? And for the release is important. So I have 1, 2, 3, 4. That works. Okay. Good. Okay, so now I have this vector 2, right? What I am going to be wanting then is to give the player some movement. So now, in order to do this, we're going to need to be aware of the movement of its character controller. So let's do character controller. We're going to need a reference to this. A character controller. It's going to be of public type so that I can see it in the console. We're going to do a header here. Header references to other game objects or components. We're going to have a character controller component. We are going to and we are going to totally lost the thread. We are going to call it controller. Just controller component. Just controller component. Then here, let's just space this out a little bit. This is going to be context. We're going to call it context. Gonna use the full word just so that I don't forget what this means. Context. And then we should be set. So if I save this, I am now able to grab you and tell the movement execution script that the character controller exists. Good. So now what I need to do is use this vector to control the character's movement, right? The character's movement should be controlled in the fixed update method so that it follows physics-ish update cycles, and it should also be using this. So every time this happens, we want to store this vector into a variable. So let's call this header movement variables, and variables. This is going to be a public so that I can see it in the inspector, really. I don't think I'm going to be fiddling with it. Actually, is there a show in inspector thing that I can do? Because there is hide in inspector. Can I have just like a private variable that I can show in the inspector no matter what? Let's see. Movement. It's a vector2 type. Vector2, and it's going to be a movement vector, right? And so what this is going to do is we're going to go into, we're going to check this. We're going to take this value that we read from the action callback, and we're going to store it into that variable. So movement vector. We also need to make sure that movement vector is correctly initialized. So public void, actually not public, just void awake. Actually, do I want it on awake or do I want it on start? I don't want it on start, really. Can't think of a reason to have it on awake. Start movement vector is going to begin by being equal to the 0 vector, so equals vector 2.0. The type names shown in inspector attribute could not be found. Are you okay? So that's not a thing. Okay. Can I have show in inspector unity? I want to show a private variable in the inspector. Okay, variables and the inspector. When you create a script in the editor, Unity automatically provides a template script which inherits from the MonoBehavior class. Inheriting from the MonoBehavior class means your script can behave like a type of component, and you can attach it to game objects like any other component. When your script inherits from MonoBehavior, you can include properties and values in your script, which you can then edit from the editor inspector, like you can with any other component. The example code below declares I know that already. To create the inspector label, Unity inserts a space between lowercase and uppercase characters in the variable name. Apply several other rules. However, these changes are purely for display purposes. You should always use the variable name within your code. You edit my name, value, okay. Object reference fields. As well as bool, string, and numeric fields, you can also make any field whose type inherits from Unity Engine Point object editable in the inspector. This includes all built-in components, just transform, audio source, camera, light, your own MonoBehavior script types, and many asset types. This allows you to make use of the Unity editor's powerful drag-and-drop system in your own scripted component, blah 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 blah, whatever. In the screenshot, there is variable name to library conversion. You know what? This is more effort than it's worth. I'm just gonna make it public. Fucking sue me. Okay. Slept too late. Alright, that's what I'm... So, okay, so I'm looking at this, right? I want to make sure that this is being edited the way it should. And it is. It's working beautifully. Okay, that's good. That means that I can use that vector to decide on the movement on the player. Now, this should obviously happen in the fixed update. So, void fixed update... Right, to this and to that, right. However, it's not as straightforward as it might appear, because my first instinct is obviously to like take the x component of this, take this vector 2, translate it to a vector 3, where it is, instead of being the x and the y, it's the x and the z, leave the y as 0, then move the player in that vector times a certain speed value that I'm going to have to define times dt, Actually, I don't even need to bother about delta time because that's not a variable since it's in fixed update. Actually, I should still times it by dt just for precaution, but like I'm not gonna be changing the physics update time. I don't think. So yeah, I just do that and it will work. Problem is that only works for one camera angle. I need the movement to stay relative to the camera direction, because if the camera spins, forward is suddenly non-aligned to the world axis, right? It's forward from the camera, so that needs to be taken into account. Now, this should not be an issue, because I've already done something like it, and in fact a way more complicated version of it, so I sort of know how this works. However, I'm going to pull up that script on the side so that I can use it as a reminder. It's not cheating to copy from yourself. Let me shove this to the side a little bit. This is my first project. I think I called it... Where the fuck is this? Documents, Unity, Garbage Day. It's in scripts, probably. Right, assets, player, scripts. No, it doesn't have a scripts folder. It just has all the scripts just put in there. Here, carrier, dropping damage, enemy awareness, grab, left and right, reflective one, bond grab. What the fuck is the movement? Did I put the movement is in a general one? Camera, enemy, floor, general. Activator, animation, basic move. Yeah, there it is. Okay, so this is the basic move script that I had for that carriage. It begins by... It uses rigid bodies, so it's just by default more complicated. So it gets the transform of the camera, right? It finds the main camera and then gets its transform. Then uses the... This bit I don't care. This was for tilted floors before I realized that character controller components were a thing that you could use that would do that for you. Input to direction, this is what it was. So it takes the input as a raw vector 2, which is what I have. It checks if the camera transform is null. If it is null, then we're just going to use the world axis, so we're going to skip this bit. We rotate this input, which is a vector 2, by the camera transforms Euler angles Y component. This gives you the tilt of the camera. This is assuming that the camera is always going to be aligned to the ground, right? It's vaguely horizontal on the same... Like, it's not gonna twist. It's not gonna... I forget what the term is called. It's yaw pitch, one of the two, right? But it's not going to do that. So I can just make sure that I don't move it on the Z. I don't rotate it. I don't do... Where is it? I just gotta make sure that I don't do, like... You know... Like, I can do this rotation, and I can do... What the fuck is the camera? Oh, it's over there. Okay. I can do this kind of rotation. I can do this kind of rotation. But I gotta make sure that I don't do this kind of rotation, right? Which is easy enough. Just, you know? Right. So then, we are going to need to get a reference to the camera. We are going to, first of all, begin by checking if there is an object called that camera. But we're also going to put a reference here. It's good to just have it doubled up, right? So public, we're going to want the transform of the camera. So the transform component, we're going to call it camera transform. This is the camera that the player is currently being moved relative to. Then we're going to take this camera transform and we're going to check if it is null, because if it is null, then that means that we have to find another one. Right, so if this camera transform, this camera transform is null, then we're going to just find another camera that has the name main camera, and we're going to assign that its transform as our camera transform. Then what we're going to do in fixed update is rotate that camera, yeah, we're going to Yeah, we want to grab this input direction. Yes, so we want something like this. Right. So this is what we're going to do. We are going to receive a raw input. This is just the vector2 that we received from here. Also, it shouldn't be called debuggy. It should be called receive input, right? It's fine. It's receive input within this context, right? So actually, if it's public, no, it's receive input within the movement execution context, right? So it's fine that the name is somewhat generic, right? Because it's always going to be referenced as movement execution point receive input. So which input? The input of the movement execution. So we know that it's not going to be confused on receiving other inputs from jumps or other actions that I may have. Input to direction, vector2.raw, right. This takes a vector2, which is the raw input, is the one that we received here. It takes the camera, it checks if the camera transform is null. If it's not, it's going to rotate that raw input by the Y rotation component of the camera's transform. This makes it so that if the camera rotates, the player still is moving relative to that camera. So forward is forward on the screen instead of forward on the world axis, right? Then we want to grab that resulting vector. This is a vector 2. We want to make a vector 3 so that it's in 3D space. So we take its x component and its y component. We decide that it's going to be the x and the z of a new vector 3 component, save it in the result, and return that. So in order to use this, really what I have to do is hold this, and let's change the name to something a bit more telling. Let's go to rotate to camera. I'm going to rotate our raw movement vector. And in fact, let's not call it movement vector. That's a bad name because that implies that it's the resulting movement vector and not just the input vector. So let's call it the input vector. Input vector. Input vector as opposed to just input, because input might be confused by the actual raw input, the input action callback stuff, right? Input vector. Anything else that I need to change? No, just this. Okay, input vector. So they should all be the same now. So now we want to take this input vector, rotate it around the camera, rotate to camera. We're going to get as a result a vector 3. This vector 3 is our actual movement vector. So public vector 3 movement vector. Let's leave it at that so that I can actually test that out. Also, these shouldn't be uppercase. Why did I type it in uppercase? Movement vector. Yes. Input vector. Input vector. Input vector. Also, let's make sure that the movement vector is initialized at 0 as well. This shouldn't be an issue anyways, but just I like to be oversure with these things. And then yeah, that should do it. So then what I should get, now hold on, I'm realizing something. Right, this is receiving input. So how am I going to generalize this for when I want to use it for control of something else, right? It's going to still have this function that it's just never going to execute because those things don't have their own thing. So I would have to have another function that calls these method, that calls an equivalent method here. Or not even, just that touches this vector directly. That should be it, really. Hold on, then rotate to camera. Does that need to happen? Yeah, because then that would be in world value, shouldn't it? Right, because these creatures are not going to care about the camera, are they? They're just gonna care about the world positions. So I may not want to actually generalize this much. Let's call this player movement and then have another one that is actually movement execution. Shouldn't we? And that movement execution can be common amongst enemies because all it's going to need is this resulting vector 3, right? But however though, as much as I don't need to rotate them to the floor, I still... No, you know what? Giving them a resulting vector 3 does work for generalizing this. So I'm going to need to change the name of this because movement execution does not any longer work. This is player decision, player movement decision, really. So let's call it player movement, player input. No, that doesn't work. Let's just call it player movement. Sure, player movement, and this is going to break a bunch of stuff. I'm going to have to, yep, this. Then take this rotate to camera. I want the result of that to be put into this movement vector. I'm going to equal this. And then let's change the... What do you mean rotate to floor doesn't exist? Oh, it's rotate to camera. Wait, hold on. What is rotate to floor? Yeah, no, don't fucking bother with this. This is fine. Just return the result. It does not exist. What do you mean rotate doesn't exist? Oh, is rotate a function that I had defined here? Oh, it is. Well, it's fine. This is just vector maths. I can just copy and paste this without any thought. This is just rotating a vector 2 along a certain specific angle. Yep, this is all I need. Right, so why are you not complaining that the name is different? The name is different. That should be an issue to you. Let's just copy this name. And then rename it to player movement. There you go. Okay. Now I have this player movement. Yeah, not this. Now I have this player movement script that should be changing a vector 3 within it as a result of my key presses. So let's see. I go forward and nothing is happening. Right, it's because you're still Right, it's because you don't know what the camera transform is. Let's give you this. Although that should make a difference. Yeah, nothing is happening. So what the heck happened? Oh, it's because the player input doesn't any longer know what that script is called since I changed this name. So your player, not player movement, player input, not player movement. Your player movement receive input. Right. So yeah, you can see that the X becomes the X and the Y becomes the C because we don't want it to go up, we want it to go forwards and backwards. When I do the diagonals, they mimic perfectly. Now what's interesting, if this worked, should be this. If I rotate the camera, say 90 degrees, then they should be switched and the X should become the Z and the Y should become the X, and also one of them maybe should be reversed. Yeah, that's -4 point to the E, so that's like a tiny number, right? Right, just a floating math error, but can safely be disregarded, right? And this means that the movement is now relative to the camera instead of relative to the world axis, right? Of course, the movement doesn't yet happen. That is something that is going to happen in a different script. And it's going to happen in a different script as a way to generalize that basic movement script as something that only takes a vector 3 and then moves a character controller in a certain direction, accounting for gravity and other stuff, so that it can then be reused for other entities that may not necessarily want to have a keyboard, may not want to be listening to keyboard inputs, right? May want to listen to their own logic to move and such. Generalizing, always the fun part of scripting. So then, since that script is going to be generalized, let's create a new folder for those kinds of script and call it general. This is for things that are going to be used in more than one entity. I'm going to create a new folder within it that is for scripts, because I assume that I'm going to have more than one of those. This is going to be basic movement. Right, so now the player is going to need one of those scripts, right? This script is kind of subordinate to this player movement script, and also this means that, just tangent here, this means that if I want to take control of the player for any reason, all I have to do is break the relationship between player movement and basic movement script and just give it something else in replacement. That can be useful for, say, something like a cutscene where I may want the player to move in a certain direction and stop listening to keyboard inputs, or say, for example, like a dizzying effect that makes you move in just a random direction, or anything. That's the beauty of generalizing your code, isn't it? Oh my god, shut up. There you go, this basic movement. So how should a relationship be established, right? So the first thing that I can think of is having player movement call a function that basic movement, that forces basic movement to change its movement vector. But is that really the best way? Should maybe basic movement listen to player movement specifically? But that means the player movement needs to have a reference to that component, and it may not be that component that I want. This player movement is just for listening to inputs, and I may want it for things that are not inputs, so I may want something more general. Calling a Unity event, though, means that basic movement cannot do anything on its own. But actually, I don't want it to do anything on its own. It's supposed to move things according to input from others. That's what basic movement is for. Yeah, let's have it be a event that gets called. So, this is going to take some finagling though, because basic movement is going to want... Also, that means the player movement doesn't actually need to know who its controller component is, will it? Who the character controller is. It doesn't move it, it just changes this variable. Also, since I already tested that these work, these should now be private. Just, these have no reason to be changed in the inspector. Now, you are going to need to know who the controller component is. So let's begin by having you... No, actually, never mind. Okay, so what this should do is it should have a function that receives... Yeah, it should have a function that receives a vector 3 and then moves according to it. So vector public void vector. Yeah, this is going to be a change movement vector. Would be the obvious name, but that feels a bit lengthy. Assign vector, maybe assign vector. Receive movement. Receive movement. That works. Receive direction, maybe. Receive direction. Yes, receiving the direction in which you are going to be moving. Receive direction. And this is going to receive a vector 3. A vector 3 that is going to be called direction. It's the direction that we're going to be moving in. It's a vector 3. And we're going to, for now, just store that into its own... variable. So movement variables public vector 3 movement direction vector movement direction, right? So for now, all that we're going to do is take this direction and store it in movement direction. Also, I need to stop giving these uppercase. Movement direction, right? Movement direction equals the direction that we've just been given. Now, what I need to do is find a way to call this as a Unity event. The problem with these Unity events is that they don't natively have thing to just receive any type of variable. Unity engine point events, I think that was called. Unity event. Scripting API, Unity event, zero argument persistent callback that can be saved within the C. Unity engine point events. Yes, events. This is the library that I want to use. So, yeah. We're going to need another header that is for events, and this just have a Unity event. But actually, do I want it to be a Unity event? Maybe I want it. Maybe there's an event that will just do abstract class. No, that's not what I want. Implemented in core module. Core module? Oh, that I don't have that. Never. Unity event. Point my event. Class. It's a class in Unity Engine Point event. Unity event is the constructor. Can I get this constructor to construct something that an event that listens to something else? That passes a variable, right? Class in Unity Engine Point events. Well, can I go to Unity Engine Point events, please? Classes. Oh, they're there. Okay. Unity Engine Point events. T0. One argument version of Unity event. If you wish to use a generic Unity event type, you must override the class type. So public class my int event. Oh, so I have to do it that way? Okay, that's a bit odd. I don't exactly understand what is going on, but I'll just copy the code because I know that it works. So this is an event definition. I want this to be serializable so that I can put it into the thing. I want this to be a public class vector event. Unity event vector 3. Should it be a vector? Yeah, it should be a vector 3. Vector 3. And then do it like this. So then I can just take this here. And then on these events, I can define one of those vector events. Say that I want to have a public vector event that is going to be called send. What did I call it here so that they match? Send direction. Yes, send direction. And so I can yes, then I can, whenever I edit this movement vector, I can just do send direction. Do you have any events added? If so, invoke with the parameter movement. Actually, I probably don't need to store it here. I can probably just send it and be done with it. Input vector. Actually, this should happen in update, shouldn't it? Because we're not yet doing the actual movement. Hey, Steve, what's up? So, I do this, right. So then it should be sending. Let's properly check that it's sending. So, save all that, go back to Unity. Hey, for once I'm actually excited in the project I'm gonna be making. I managed to partner up with somebody who I actually think is very cool. It's the same person that I did the first project in the last semester, so this is all looking to be very nice. I really don't want to disappoint though for that very same reason. Although she doesn't seem like somebody who would give me too much shit about it. So the player movement calls the basic movement, it goes to the basic movement, it receives, it sends this direction. Not much, glad to hear you got a good project to work on this time. Yeah, I'm actually quite excited about the idea that she came up with. Well, she came up with a very basic idea and then we developed it further. It was very good. It's a very good idea and it's the kind of thing that I really want to learn how to do, which is a rhythm game platformer. I don't remember if I told you about this. But yeah, she wanted us to do a rhythm platformer, and I told her, at first I was a bit iffy because I was like, that's a bit difficult to make, right? And so I was giving her a couple of options on things that may be easier to build. But then the more I thought about that, and the more I thought about those options, I realized that, no, actually it's not that difficult to make. Just gotta have some design considerations. So it's kind of a rhythm platformer, but you're not actually tied to the beat of the song. Rather, the timing of your actions is the same as the BPM of the background music. So that means that if you land off time, you can absolutely still execute every action, so long as you're always perfectly off time, right? So that means that as a developer, I don't have to keep track of the tempo of the background music. I can just check it beforehand and be like, okay, this music is at 250 BPM, so actions have to be performed at 250 BPM. And I don't have to keep track of where in the song we are right now to see if you landed on beat or off beat. Off beat is fine so long as you're consistently off beat. That's the whole idea. Which, like, as a game mechanic, doesn't even seem that bad. Okay, so that should work. So now what we should see is these numbers begin to change as I press the buttons. And that means that the two scripts are communicating correctly. Then I press. It works. It just works. It just completely works. That's good. Okay, so now I need to make sure that you know who the character controller is. It's this guy. And then I need to use this resulting vector to actually move the character. So, since this game is a 3D platformer, or at least that's the idea, we are going to want the movement to have a certain momentum, right? I can't just have that vector be applied, but let's try doing that to begin with anyways. Just to check that everything is working the way that it should. So we go to our void fixed update function. And in here, we're going to take reference of this character controller component, and we are going to I think the function is just called move, and then it should receive a vector 3 type variable. So controller component, look it up on the Unity specifications, character controller. That's a collision snip with slope. Move and simple move. Okay, move and simple move. What's the difference? Move supplies the movement with attached game controller character control component. Motion moves the object in the given motion. The given direction requires absolute movement delta values. A collision constrains the move from taking place. The turn collision flags indicate the direction of a collision, and it does not use gravity. Move simple moves a character with speed. With speed? It is recommended you only make one call to move or simple move per frame. This is something that's important, so I'm going to write it here in really big letters. Only one move or simple move call per frame. There we go. And I assume that by frame it means physics update frames, not actual frames. Because otherwise I'm host. Right. So, do I want to use simple move and calculate the velocity myself? Or do I want to use move and give it those deltas? It's in units per second. Because see, something that I could do is just take this vector 3 direction, normalize it, and then decide on the direction myself. That way I can keep direct track of the speed of this character. Okay, how would I do this if I did this with normal move? I'd have to give it a displacement. So I would have to keep track of that velocity, then convert that velocity to displacement, and only then move. Which wouldn't be even that difficult, it's just taking the actual resulting move direction and multiplying that by the speed that I get. But the speed is in vector 3s anyway. Oh, Right, because the normal move, what it does is displacement. So if the thing is at position 1, and then I give it a vector that is pointing 1 to the right, then the next frame is going to be at position 1 to the right, so at position 2. Whereas if I give it speed, I would give it in units per second, so I would have to give it... yeah, I don't know precisely where it's going to be, but I know how much it's going to move in a second if I keep applying the same movement. So... I think I want that. Okay, let's do simple move. Let's do simple move. Simple move. Yeah, let's do simple move and then give it this movement direction that we have calculated, but this is just 1 unit per second always, except when it's 0. So let's create another variable. Actually, let's call it a property, right, for now. So header, because this is not something that's going to, this is something that you're going to move through the editor. So movement properties or settings, same thing really. Properties, also this should be separate. Then public float vector. No, not a vector. It's just speed, movement speed. So then take the movement direction multiplied by movement speed. Should these be called in update? This thing is calling them in update. I don't like that. I wish that you would call them in. Okay, well, can be an issue anyway. Do I have to take into account delta time? Surely not, right? Because if I'm giving it a speed and the speed is in things per second, then it should take into account it. It should take it into account for me, because otherwise, how would it know that it is units per second? It would just be units per certain amount of frames, right? So yeah, this probably itself already does the delta time calculation for me, if I had to guess. So this should cause it to move at a consistent just speed that I set up. This is not what I want the final movement to look like, but as a test, this should be good enough. Okay, so let's see if that works, and just bypassing, we'll see also if my calculations for the camera rotation are valid. So first of all, let's put our camera in a bit of a more pleasant position. Somewhere that seems a bit more natural. Yeah, there you go. Right. Do you see anything move? I don't really. The camera is definitely not following the player because I haven't done that yet. The basic movement is... Oh, because speed is 0, right. Let's say that speed is 1 instead. It moves, okay. 1 is too small. Let's make it 5. It moves. As a proof of concept, it works. Okay. Now, here's the test. The actual big test. If I take this camera and rotate it, oop, not that way, rotate it like this, and place it here. Will the player movement be relative to the camera instead of the... Yeah, it is. It is. So see, I'm pressing forward now, right? Which means that the movement is not relative to the world axis, is actually relative to the camera position. Okay. So that's a big success. Let's now actually see about coding that velocity, that momentum. That is what makes 3D platformers and platformers in general seem so good. First of all, we're going to need a variable that is the actual current speed. Public load, it is the current movement speed. Current speed. Right? So, it is useful here to think about how something like Mario 64 and some other 3D platformers do it, because Mario 64 does it in a way that is intuitively makes sense, but that actually ends up feeling quite bad when you play it. And that is that momentum is carried as you run, such that if you stop pressing the button, you come to a halt slowly over time. That part is fine. What is a problem is that when you push the stick in the opposite direction, Mario doesn't try to stop and move in that other direction. He instead tries to rotate himself to conserve that momentum. And that is what fucks you up so much when you're playing, is that sometimes Mario, instead of turning right around, he will do like a little turn and that'll lead you off of the platform. This is because he's trying to conserve the momentum that he has, right? And so when you push him in the opposite direction, he's going to want to, instead of killing his velocity, he's going to want to turn with the velocity, right? So, perhaps what should be done is Right, because how much velocity you lose should depend on the direction, shouldn't it? If you're pushing towards any other direction, we shouldn't just get your momentum. We should reduce it by the amount depending on which direction it is. If you're pushing to a similar direction, you shouldn't lose much. If you're pushing in a complete opposite direction, then yeah, you should lose all your momentum first, and then only then start going in the opposite direction. But how do we decide which directions are opposite and how opposite they are? There has to be a mathematical way to do this. Actually, isn't there just a formula that Unity gives you for 2D vectors that can tell you whether they're parallel or whether they're pointing in opposite directions or something? And like how opposite they are? Actually, I wouldn't even need to. I just need to know the angle between those two vectors. And if the angle is between 0 and 90 degrees in either side, then we're pointing forwards. And if the angle is between 90 and 180 degrees on both sides, then the angle is pointing in the opposite direction. If it's pointing in the opposite direction, it'll push you. Hold on, no, I'm doing it the way that Mario 64 did it. That's not the way that you should do it. No, what you have to do is do it the way that something like Mario Galaxy does it. Does Mario Galaxy just immediately give you momentum in the direction that you're pushing regardless of anything? But then the opposite direction is the issue. So should I have an opposite because you should have a little bit of braking time if you suddenly push in immediately opposite direction. But that shouldn't apply when you're pushing to the sides. Then you should just turn on a dime, right? Like turning speed should not be an issue for somebody who's walking on foot. You can just do brakes, right? Let's watch some footage of Mario Galaxy and see how it does it, because regardless of whether you like or don't like Mario games, the truth is that they have the base movement down to a science, don't they? Here we go. Okay. So, just a random point. I want to see Mario turn is what I want to see. Right, of course I caught just the cutscene. Okay, there should be a lot of turning here. Okay, so let's see how this works. Let me watch it in slow motion so that I can see it better. Okay, Mario runs. When he turns, like I want to see a sudden turn, right? Yeah, but like during movement. Okay, that's a turn. That's a good turn. Okay. So Mario is moving at a certain velocity. When he decides to turn, he just turns really quickly, right? So like it seems like he gets to just conserve velocity so long as he's pushing the movement stick. What I want to see is when he turns to the other side, does he do like a sudden break? Yeah, just give me somewhere to where I can see that. Oh, that's way too short. Hmm. Not much to see there. Come on. Yeah, come on, just I want a level where you control Mario, please. Not a cutscene would be nice. Okay, I think that was a pretty quick turnaround. Let's see what that was. So Mario. Can I find one of the racing levels? I want to see more continuous flowing movement. Okay, let me see if I can find Blue Comet, Mario Galaxy. I'm pretty sure that was the name of the thing. All Cosmic Comet missions, okay. Okay, I want to see this. I should be able to see some movement, to get a good look at Mario's movement here. This guy's gonna long jump the whole way, isn't he? Yeah, that doesn't help me that much. Yeah, I want to see him turn around is the issue. This is just ice, so that's not gonna give me anything. Okay, this one might, though. Oh, come on, just do a turnaround. Just do a quick U-turn. That's what I want you to do. Just do like a U-turn or like... Yeah, this doesn't help me either. Also doesn't help me. Oh, okay. Okay. So I'm gonna have to wing it a little bit, but I think I sort of have an intuition about how he should move backwards. Like, I think that what should happen is just it should turn around very, very quickly. Right, because if I let you just conserve your momentum, it runs the risk of feeling like you're just bouncing on the floor, right? Whereas what Mario seems to do is that he still has the weird Mario 64 car controls where he tries to turn, but just he maneuvers so much better that you don't notice it, right? Like he still turns around a little bit, but that turn around happens in like less than half a second, as opposed to like the slow, long, wide turns that he would take in 64. I think that's what's happening, so I think that's what I'm gonna have to try to emulate, which means that the actual movement angle is going to have to be rotated along the received movement angle. So that is going to have to change. So speed should be max speed, and yeah, let's start with that. Let's start just seeing the speed go up or down. So, current speed should always start at 0. Max speed should probably be what we saw in there, so let's put it as 8. It's an 8 floating point number. These are open to the inspector, so these default values actually don't matter. Then what I want, before we do the simple move, the movement direction should not be the only thing happening here. When you receive a direction, that should be stored into a desired direction. That's the direction that desired direction. That's the direction that the player is currently inputting. But the actual direction that we're going to move in is going to depend on a bunch of other factors, right? That should be the current direction on public public vector 3 current direction. Now the thing about these directions is that because they're going to be multiplied by this speed variable, they're going to have to always be normalized. For the desired direction, that's fine, because you always receive desired directions from, you always release normalized values from input. But the current direction might not be, so we have to take care of that. Also, I'm going to go to the restroom, so give me 1 second. Sure. I have returned. Okay. So we have the desired direction that is always going to be normalized. We have the... Actually, should it always be normalized? Because I'm realizing that you don't always receive normalized directions from the input. You only do because it's a keyboard, but sometimes it's something in between. Sometimes you're not pushing the stick the whole way. But actually, if it's not being pushed the whole way, and then that's fine too, because it's still in the range of 0 to 1. That's the important thing. So, okay. We want the current movement direction. So okay. We want the current direction to change based on a couple of factors. Chief among them is the current direction that we're already moving at and the desired direction. So like if you want to move to the left but you're moving forward, then you should have a little bit of time where you turn to the left, right? So your actual resulting movement should be first to the diagonal and then all the way right, left, may I say. So yeah, the direction ones don't care about magnitude, right? So also yes. Let's not worry about magnitude for now and just assume that all movement is full on or nothing at all, right? And then we'll add the magnitude of the movement later, because I think I have a way that I can do that without being destructive to the rest of the calculation. So, first of all, the resulting current direction, what should it be? Current direction should be equal to it certainly should be an operation that is done to the current direction that we already had, the one that we had previously, and with the desired direction. So now let's see, what operations can we do on vector 3? So vector 3. Unity API scripting vector 3. We have the following operations. We have, and I'm pretty sure that, oh, I forgot to take away the BRB screen. Home professional. Okay, so we have, these are the properties, we don't care about those. More properties. Constructors, public methods. We can check if a vector is equal to another. We can set the components of a particular vector. We can return a formatted string for the vector. We can calculate the angle between two vectors. We can return a copy of the vector with its magnitude clamped to a certain length. Cross product two vectors. We can return the distance between two vectors. Dot product. Linearly interpolate. Now that kind of works, but the problem with that is that bigger turns should occur faster, not all at the same rate. So the lerp doesn't exactly work. Maximum and minimum, so the longest and the shortest of two vectors. Calculate the position between the points specified by the current moving no further than distance specified. Okay, but this is for distance. What I want is angle. Normalize, make a vector equal magnitude equal to 1. Orthonormalize, make vectors normalized and orthogonal to each other. What does that mean? Normalize is normal, normalize is tangent, and make sure it is orthogonal to normal. That is, the angle between them is 90 degrees. Oh, okay. Oh, okay, but that's okay. That's useful, but that's not something I want. Project onto another vector. Project a vector onto a plane. Reflect a vector. Rotate towards. I think this is what I want. So, you have a current vector. You have a target. You have the max radius turn and the max magnitude to delta. Yeah, I think this is what I want. So let's use this. I think this is what I want. So on vector 3 rotate towards, it's written like so. The vector that I want is going to be equal to taking this current vector, rotating it towards a particular target, which is the direction that I want to move towards, and we want the max radius to turn. Now this should be a property that is called the maneuverability. Public float. It's going to be the maneuverable maneuverability. Maneuverability. Yeah, that sounds right. Maneuverability. And we're going to pin this as 0f, just forget. Actually, let's pin it as 1f. This is in radians, so 1f should actually be quite a lot of maneuverability. Maneuverability, that's where I was getting hanged. Snagged. And the maximum magnitude delta should probably be 1. Like, if the magnitude changes between these two things, I want it to change the whole way. I don't want there to be easing. If you want to slow down by pushing less hard on the stick, it should just happen, right? That's right. It's like... Because hold on, that completely... I could just normalize the result and then apply the current speed, right? Yeah, let's just normalize the result. Take this is going to return a vector, then just normalized. How did the normalize thing work? It was uppercase? Oh, okay. So it is a method, not a property. That's unexpected. Okay, then never mind. It's not written like this. Then it's written like this: vector 3 point normalized with an uppercase n. And what you want to normalize is the result of rotating the vector towards the other vector. And that should give us a bit of turning momentum. It's not going to be exactly what we want. Oh, right. And then this current direction should be what we move towards. Desired direction. Okay, so I misspelled something somewhere. Desired direction. Yes. Vector 3 does not contain a definition for normal. What do you mean it doesn't? I know that it does. I just saw it. Is it because I'm using a different version? I'm using 2021.3. Because it's not normalized. It's normalized. I'm telling it to normalize. That makes sense. Rotate towards does not exist. Okay, what do you mean it doesn't exist? I just saw it. Like, okay, this one surely is because I'm in a different version. 1.3, right? Rotate towards. What? Oh, right, because it's right, because it's something that's inside vector 3, not just floating in the middle of nowhere. So it's vector 3 point rotate towards. So then I take the player, and I'm gonna have to play with these values a little bit. These two. Max speed is not going to change anything. It's not used for the moment, but the maneuverability might. Right. I forgot to multiply this by the speed though. Max speed. Okay. So 1 might be a bit too high. Like I can feel it, but I can't feel it much, right? So let's, if it's 0, it should just not let me turn, right? Like I can start movement in any direction, but I have to stop before I start again. If it's 0.1, right? It takes a bit to turn. So let's make it 0.3. 0.3 is a lot, so let's make it 0.2 actually. Hmm. 0.13. I do like how this feels. But there's a thing. This is rotating by 1.3, but this is gonna be different whether it's an update or in fixed update, right? Like, if the frame rate is longer, your maneuverability changes too. The maneuverability shouldn't be in units per frame, it should be in units per second. The issue with that is that now I have to multiply this by time point delta time, aren't I? So, time point delta time. So that's gonna give me completely different numbers, although it might make the value easier to play with, actually. If the maneuverability is 1, it is no longer 1 radian per frame, it's now 1 radian per second. That may be a whole lot better. Oh god. Okay. Oh, because I'm an idiot and what I changed was not the... Yeah, this is not what I wanted to multiply by delta time. It's this. Alright, so then I get a movement that should be able to, like, not turn on a dime, right? Okay, that's way too slow. Let's change this value. Because a radian per second is a half turn. No, it's not a half turn. It's like a quarter turn divided by pi, you know what I mean? So let's make it something like 5 and see what I get. Yeah, that's way too wide of a turn. That looks like Mario 64. So what if I make it like 9, right? Yeah, that's reasonable. Like, what if I try to, like, move like this? Yeah, like, you still have some weight to yourself, but it's not enough to get in the way of where you want to move. Like, if you want to maneuver really tightly, that weight is going to get in the way, but, like, otherwise, you can just kind of turn and move however you feel like. You still start and stop on a dime, and that's what I intend to fix next. But at least in terms of maneuverability, I like that number. Okay, so what is it? It's 9. So I want that number to be 9. Then for the speed, I have to actually make sure that that speed sort of works with things. So, yeah, I am normalizing that vector so that it's always from 0 to 1. That way, this little barrier right here doesn't really do anything. Yeah, a zero vector normalized is still a zero vector, right? It doesn't just pick a random direction and do that, right? Yeah, a zero vector normalized is still a zero vector. It still has a magnitude of 0 because it has no direction to normalize in the first place, so it's just 0. So that's fine. So I can track stopping with this variable as well. That's not going to be an issue. So then I want to actually bring the speed into the equation so that instead of using max speed, we're using this actual current speed variable. So what this should have, it should also have some manner of acceleration. Which also just maneuverability is in radians per second, right? Because we're using delta time. So, how should this work? Your velocity, your speed starts at, actually it should be velocity in physics terms, I don't really care that much. So your speed starts at 0. As you hold the button, it should go towards 8. Should it lerp? No, because a lerp will lerp from the current direction. That's not exactly what I want. So I want this number every frame to go up a certain amount. So it should go up by an I should have an acceleration variable, public acceleration, and it should be a float acceleration, right? So this acceleration should be equal to, let's say 1 for now. So speed, and let's move this over here, and let's just state that this is calculate angle or direction, really direction. So the speed, right? The current speed, we should get the magnitude of that current direction, and if it's 1, we do the acceleration, and if it's 0, we do not. Right. So current direction, get the magnitude of it, right? So now that magnitude, if this magnitude equals 0, then we're accelerating. If not, we're decelerating, right? If it equals 1, if this magnitude equals 1, it's going to be normalized. So it's always going to be either 1 or 0. So if this equals 1, then we're moving. Otherwise, we're stopping, right? So if we're moving, we want the current speed to move acceleration times delta time. So that means that the acceleration is going to be, yeah, so the max speed is in units per second. And the acceleration is in units per second, right? And I may want another variable that's for deceleration, but we'll check that out later. So we want the current speed. If we're accelerating, we want the current speed to be equal to add to it. We want to add to it acceleration times delta time. And if we are not moving, we want to add to it acceleration, we want to subtract from it acceleration from delta time, and then we have to make sure that we haven't overshot or undershot. So we don't want to be moving slower than 0, and we don't want to be moving faster than max speed. So if current speed is larger than max speed, then current speed equals max speed. And the same the other way, if the current speed is somehow smaller than 0, then the current speed must be equal to 0, and these are both floating point numbers. And then we can multiply that by the current speed, and we'll be there. Now, one acceleration might be super fucking slow acceleration, but to test the system, it'll be any number will do. So yeah, we have it right here. Okay, you're accelerating when I press, and you're decelerating the current speed when I don't press, but you also are stopping anyways. You're not slowing down this current direction. So what is going on? You're taking this current direction and you're rotating it towards... right, the problem is that the normalize here, this is becoming 0, right? So what I will want to do is calculate all this, normalize it, and then check if it's equal to 0. And if it is, then just keep the current direction as it is. So we want to current direction. We want to check we want to store this in the temporary variable. So let's take a vector3 point possible direction. We're going to make it equal to that, right? So now we're going to check this possible direction. If this possible direction, if the magnitude of it equals 0, or rather, if it doesn't equal 0, then the possible direction becomes the current direction. Otherwise, the current direction just stays as it is, because the only change that needs to happen in that case is a deceleration. So the current direction equals this. Current direction equals the possible direction, otherwise just make it 0. Right. Or not make it 0, keep it as it is. So now we should actually see that deceleration happen. So you see me accelerating, and then I decelerate, hopefully. No, it keeps accelerating. Okay. Why does it keep accelerating? Right, because now that the current direction hasn't become 0, we don't... yeah, now the current direction stays as it is. We can't check if its magnitude is 0, because if it is 0, then this never happened. So I guess what we will be checking is the possible direction. However, doing the same check twice is weird. So really what we should do is move this to here, because this is what happens when that is 0. Or rather, this is what happens when that isn't 0, and this is what happens when it is, and then the current direction can just stay as it is. Now I should be getting somewhere. Acceleration, deceleration. Okay, so now let's fiddle with these numbers and find a suitable acceleration. It should be pretty quick. So what about this? This is to full speed in a second and to slow in a second. A second is... A second is kind of slow, isn't it? But I wonder if this is half a second, right? Because the number is double this. I wonder if this is too slow. Maneuverability should probably be a bit higher. Let's make it 15, see what happens there. Yeah, this is from 0 to full speed and from full speed to 0 in half a second. I would say that this feels quite well. It's like you can feel the momentum, right? You can feel it, but it doesn't take a hold of you. You still have mostly a lot of control over this guy. Obviously, air momentum is going to be very, very, very different, right? And this level of maneuverability is, it feels great. Like it gives you a lot of weight. But you still basically don't move much if you turn. Okay, am I taking delta time into account? I feel like I may not be. You're doing this and you're doing this for the rotation and this for the speed. No, it is taken into account. Okay, okay. So we have it, right? This is the basic movement, pretty much done. What number did I land upon? It's 8, 15, and 16. Okay. 8, 15, and 16. Okay. So, okay, that's the basic movement already done. Yeah, this is the most basic of the basic movement. You have the acceleration, the deceleration, you have everything as it should be. And the cool thing is that turning on a dime does not actually mess with the acceleration because we're taking those into account. When you turn on a dime, you still retain the movement speed that you had beforehand. You just change the direction, and by changing it really quickly is that you move in the opposite direction, not by subtracting speed. So that means that turns can be a little bit wider than you may be expecting, but you turn so quickly anyway that this is not an issue, right? It's not something that gets in the way, it's just something that adds weight to the feeling of the character, which is very important for a platformer. So, I was meaning to do camera movement today, but I get the feeling that's not going to be very straightforward. So I'll leave it for tomorrow, but I will do it tomorrow, and I will do it on stream as well. But I think I'm done with this for today. I think that as a starter, this is very, very good. And we'll see. Yeah. Thanks for coming in. I assume you're Steve. Bye bye.